Thank you. Olaniyi Awe is my name, Department of Material Science and Engineering, Obafemi Awolowo University, Nigeria. I will be speaking on the topic that says characterization of Itagunmodi, Southern Nigeria, alluvial gold ore nanoparticles using SEM-EDX method. Let me give a small background of this research work. The thrust of the work is to understand the nature of gold ore that are abundant in the southwestern Nigeria. And the purpose of this is to determine suitable method for the beneficiation and the extraction of gold. In the course of this presentation, I'll be speaking principally on the research methodology used, the result obtained, and also conclusion. As to the raw material here is gold ore, and gold is touted to be the king of metal because of its outstanding qualities. Unlike other metals that can easily be affected by the environment or harsh condition, gold withstand or can work under such harsh condition. It has a symbol of AU and the atomic number of 79. However, in this research field that where we got the sample, it was found that gold ore occurred in two different forms, one in the lode form and the other one in the alluvial form. And when you are to put value into the value of the ore deposit, gold ore deposit in the southwest Nigeria, Itagunmodi in particular, it is put at the amount of about $5 billion. And so that shows that it's a worthwhile investment. But over time, what we find on field is that those that are working on this field have been working on the alluvial gold, ones that are gold ore, ones that have been washed away over years by erosion and that have settled in some riverine area. But when you look at their procedures and method, we find out that the method being used, which is the panning method, the use of gravitational method of panning, traditional panning, for separation of the gold ore, we found out that the method is not adequate enough because some of these value materials have been lost into the tailing, and that informs us the need to really understudy the ore material so as to be able to improve on the present procedure being used and also maybe perhaps to introduce another method. So like I've mentioned, some of the concern that led us to this research work is that the process being used currently, which is the panning method, the use of panning to get the desired gold metal is unregulated and less effective because most of the values are lost into the tailings. And there's also environmental degradation because the process is not being controlled. People are not much concerned about what are in the tailings that they are being scattered in the environment of the study. So we feel that it requires that the process currently being used is optimized, and also perhaps we may be able to come up with another method through which we can be able to get reasonable quantity of gold that will justify the effort being put into it. So as a framework for this research work, we obtained the gold ore sample. And with this gold sample, which serves as our fish sample, we have to conduct comprehensive analysis. And that's where the subject of nanomaterials and testing comes in. We must have good understanding of this ore so as to be able to determine whether we want to build or we want to optimize the current procedure being used, which is panning, or we outrightly want to discard that and bring out another method through which we can adequately adapt to the peculiarity of the ore materials and be able to refine or extract gold in quantity that will justify the effort being put in. So EDX or SEM is one of the tools in material science today that are used in the study of material and their chemical composition. The next slide, please. So this 2.0, which talk about the method used in the research work. Like I've mentioned, we visited the site to obtain the samples to be used to analyze and also to observe the current that is presently being used. Because one thing is that for us to build on a existing process, we have to understudy it and also study the field sample so as to be able to determine where we need to assist and also make some recommendation. Samples were obtained, and these samples were also characterized or they were weighed and also labeled appropriately, so that we can accurately measure their response to procedure and further treatment. And thereafter, this sample was later subjected to nano testing using SEM and EDX tests. The objective of using the SEM and EDX test is for us to be able to determine the nature of the ore, and more importantly, the elements that are in the ore. Determination of these elements that are in the ore will determine the mineral processing procedure to be used. For example, a mineral ore that contains sulfur in large quantity, it will be very hazardous to start using pyrometallurgy, that is the application of heat, as that will mean that the environment safety is being jeopardized. So understanding the nature of the ore can inform us or give us adequate knowledge as to what method to be used. And we decide to use EDX because EDX is a dual purpose equipment. It can give us the topography, the surface information of the ore, and also elemental composition of the ore. So the sample used, after we have already classified them and labeled them, they were properly taken care of so as to prevent contamination, because any external addition to the sample can alter the genuineness of the result. And after labeling properly, we are now put into the equipment for analysis. The next slide. Okay. This is the section showing how the ore sample were arranged in the SEM-EDX equipment. They were properly labeled and they were also arranged. Samples were grounded and were made into pellets. And in this section, you can see about 9 of such samples arranged in a section in the order of the SEM equipment for analysis. Each of these samples is well studied to determine their morphology, and not only that, to also determine the elements that are present, so that we can be well informed as to determine the process to be used to extract the desired metal, and that is good, that is precious to us. The result. The plate 2 shows the scanning electron microscope result for Itagunmodi ore. That is field sample 1. Ordinarily, micrograph from SEM is usually in black and white, as in plate 2.1. But for us to also vary it under different light to see the behavior or the morphology or the surface structure of the ore, we have to apply different light of the equipment to see, so that any form of alteration or any form of deviation can easily be picked. And that was done at a very high resolution so as to determine the morphology and the structure of the ore material, that is the gold ore. The objective of doing all of this, like I mentioned, is for us to be able to determine what other associated minerals are present in the gold ore, so as to determine how to remove the unwanted mineral, leaving behind the gold for further processing. 3 other methods were used when we are using this equipment. A particular spot in the micrograph is picked, and we were able to analyze what other mineral or elements are present around such a location. The other method that was also used is to scan through the whole sample, so that if those elements that we were unable to pick at a point, perhaps and peradventure they may be picked during the scanning of the whole sample material. The next slide. This is a typical report for spot analysis. Like I've mentioned, the SEM provides the first image, that is the high resolution image of the ore sample at a very high resolution. And the diffraction pattern shows elements that are present at a particular location. The point painted red on the enlarged sample, we were able to analyze that spot and find out the following elements are present around that spot on the sample. And these elements principally are aluminum, silicon, and lead. Definitely, all of these elements will not probably exist in isolation or in pure metal state. They exist in combined or in a compound form. And that's why we have oxygen in abundant quantity. Like SiN, we have it as quartz. We also have the aluminum oxide to aluminum and some other, like lead, we have it as galena. So for analysis of that point, we are able to see that around that point of the sample, we have these 3 or 4 principal elements that are present. And the beauty of the SEM-EDX also is for us to put values or quantity into them, so as to determine which of more of these unwanted elements are in abundance, and also to inform us what method to be used to make sure that we actually separate them to have the concentrate good, which can later be refined to have the pure good. The next slide, please. When another point was also picked, and that is the point labeled red on the micrograph, we will find out that other elements that were not earlier picked were also seen. That gives us a comprehensive composition of the ore sample. And in addition to silicon and aluminum that we have picked now, we can also say that in the ore sample, that is the gold ore sample, alluvial one, we can see magnesium, we can see silicon, we can see potassium, we can see iron compound, we can see molybdenum, and some other vital mineral. Why this material testing is important is that sometimes, as mineralogists, we might be thinking that we are looking for a particular mineral, and not knowing that there are other valuable minerals of use that can also be obtained. And that explains the reason why nanomaterial testing of all samples is very critical to the extraction and extraction of metals, and also for further improvement of the present method being used, so that more of the values can actually be gotten and never to be lost into the tailings. So with this slide 4 or plate 4, we are able to see more of other elements that were not earlier picked at the first point, which are now being picked at the second spot. The next slide. And that's also point 3, an element that were also picked. Let's please move on to the next slide. When you look at the point selected, the one that is that is more whitish, that area, when analyzed, shows that principally elements like magnesium, iron, we also have silicon, aluminum, titanium are present in the ore sample. Of importance here to note is that at this very location, we have more of iron compound than any other element present around that. But you find out that we mentioned that we are working on gold ore. And in all of the earlier shown slides, we've not been able to see gold. The reason simply being that we were only picking spots in the enlarged micrograph. So the possibility or the probability of picking gold may also be limited. And for us to now determine whether the desired metal is actually present in the ore or not, we did scanning. Scanning using SEM-EDX equipment will help us to scan through the whole sample so as to pick all other metals that were not earlier picked when we did spot check or spot scanning. Can you move on to the next slide? Thank you. That is similar to other ones that earlier been shown. Please move on so that we can also talk about the application. The next slide, please. Yes, like I've said, speed scanning was also done on the samples, so that spots that were not elements that were not picked during the spot checking or spot scanning of the sample can perhaps be picked using the scanning method. And the procedure is that the equipment will scan through the sample over a period of time and be able to come up with other elements in addition to what has earlier been picked during the spot checking or spot testing of the material. We tested a number of spots on each of the samples. We were able to pick a whole lot of elements present in the ore, but of interest to us is the gold. that we are looking after, and that is the gold, because the sample used is gold ore. And for us to also check whether in the sample we have gold in it or not, we have to do speedily scanning using the equipment, and the results were presented in table 1 and 2. Can we please look at table 1 and 2 and see the result obtained using speed scanning by SEM-EDX? That is table 1. It shows the SEM-EDX speed scanning of alluvial sample 1. And in the process, when you look through the element obtained, we have aluminum, which we have earlier seen. We have a silicon, and we also have a gold. And it's of interest to us that the gold in the sample, all over the areas in Itagunmodi, are solid gold that can be seen, because as we speak, we have quite a number of hundreds of artisanal miners in the forest searching for this gold. And once they get it in their head pan, they go to nearby stream, they do panning method to separate it, and they get the solid gold, which are later being made to undergo smelting for purification. So table 1 and table 2 shows that in the gold ore sample of Itagunmodi ore, SEM-EDX equipment was able to pick gold elements in that sample. Not only gold element, all other associated mineral elements were also picked, so as to enable us to determine how to work on the present method of gravitation, and also bring out about another method or complementary method, so as to prevent loss of values, that is gold, into the tailings of the panning method. The next slide. Next table. That's another table showing for sample 2 the presence of gold elements in the ore sample. And the beauty of it is that when you also look at the elements around this portion, you find that silicon is very enormous, having the percentage by weight of about 30%. And when you look at the fraction of gold to silicon or any other metal, you see that all other minerals that are present in the sample, they are much more abundant than gold, because gold is a very rare element, but with little quantity of gold is of great value to man. It has applications that cut across all sectors of economy and technological development. What is what can we deduce from all of these findings? Let's see how we can use the result of this SEM-EDX to appreciate the correct method that is being used. We are able to identify the minerals that are present, including gold. Let's now see how this result can be used to support the present method being used, which is gravitational method of panning, and also be used in projecting other methods of beneficiation and extraction of gold. The next slide. Yes, when we look at the list of elements earlier picked by SEM and their quantities, what can we see? Like I've said, elements were picked, and elements generally metal will occur in their compounds. We have magnesium, Mg, that's magnesium, which may also occur either as magnesite or dolomite, aluminum as aluminum. We have Si that can either exist as quartz or quartz sand, and some other mineral elements. However, what is of importance to us here is to look at the present method being used, which is gravitational method of panning. Panning method make use of differential in their gravity, specific gravity, to effect separation. Of all of these elements that have been picked and identified in this Itagunmodi gold ore, we find out that their specific gravity is far, far below the specific gravity of gold. Take, for example, the most abundant mineral, which is quartz, has the specific gravity of 2.5 to 2.8. We have also molybdenum, which whether it exists as either molybdenum or molybdenites, has its own specific gravity between 10.22 and 10.22 or less than 10.22. We have aluminum that has its own specific gravity between 3.6 to 3.9. All of these specific gravities of the mineral, associated mineral to with gold ore, their specific gravity is far, far low compared to that of gold. Gold is around 19.5 or 19.6 by specific gravity. So it means that gravity method can adequately separate gold. Why in the mixture of all of these elements or compound or their mineral. By gravity separation, gold will settle faster than any one of them. But the challenge we now have is that in the process of settling down and sedimentation of gold or fine particles can actually be lost into the tailing, because generally heavy material that are in fine powder will also behave like a light material. So that shows that the present method of gravity separation should be improved upon in such a way that the fine particles of gold that are liable to be lost to the tailing can be recovered using another method. The next slide, please. Like I've mentioned, the EDX findings show or support the dominant gravity method, like I've just explained. However, the process has to be optimized, because even though gold has greater specific gravity than any other associated mineral, the tendency is there that fine gold particles are being lost into the tailings because they will flow along with the unwanted material. And that is supported by further research in another form of research, whereby we also scan or perform experiments on the tailings of the panel. And we found out that in those tailings, we see some measure of gold that has been lost, which generally are fine powder of gold. So that means this research work is a progressive one. We're now looking at how we can build on the current panning method so as to be able to recover more of the gold values that are lost into the tailing, or outrightly use other methods. And what are these other methods that can be used, which we are working on? We can use pyro extraction, we can use mineralization, gold agglomeration, flotation of the fine particle gold, and also all of these methods can be used, and they are being correctly being studied so that we can have an holistic extraction of gold in Itagunmodi gold feed. The next slide. The next set of plates shows activities that were involved in this experimental work. We were able to understudy the artisanal miners, how they are using pan or gravity methods. And with what we have just done in this SEM testing, that shows the reason why this panning method is working for them over here. Because all of the minerals that are present that have been identified in this course of study, they were minerals whose gravity were lesser than that of gold. And that explains why this gravity method is working for them. And the other pictures show the concentrate that were obtained. The plate 4 show gold particles in various sizes, which inform us that there may be some of them that are to fine powders, which we also need to look for a way to also concentrate so that more of this precious metal can be recovered. The next slide. So that also shows the process of getting some samples, including the water in the area, for further study and analysis. Thank you.